Introduction to 3D shapes. So these are some examples of 3D shapes: sphere, cube, cuboid, cone, cylinder, triangular based pyramid, square based pyramid. Now all these shapes need to be drawn correctly to what we call as 3D drawing. Be showing both visible and the invisible part of a 3D shape. So let's start with our sphere. So the sphere can be drawn as this to show its 3 dimension, and for cube you can draw it this way. Okay, use dotted lines to show the invisible part, so we use dotted lines. And for triangular base pyramid, dotted lines as well. For cone, dotted lines as well to show the invisible part of the cone. And for prism, the same thing, so you draw dotted lines to show its 3 dimension. Similar with cuboid. And also square base pyramid, so make sure the base is square and join the dotted lines. And this is cylinder, and this is hexagonal prism. Now 3D actually stands for 3 dimensions, and the dimensions are length, width and height. And because of the height, the shape is not flat like 2D. Okay, so the shape actually takes up space. In some books they call it as fat shape. Please don't use the word fat shape, because some of your students are sensitive about that. They might be bullied by school bullies and called fat. So fat is not a good description of a 3D shape. So we need to find another or other words to describe the 3D shape. If you want to see a video on bullying where they call the victim fat, you can watch it here. Now instead of fat, you might want to use the term bulky or chunky or hefty. Okay, like hefty smurf. Okay, so all these 3 words are not words that describe human shape. Okay, so bulky, your school bag is bulky, your pencil case is bulky. It means that it has a 3D shape. Okay, so be a bit careful and be sensitive about words that you choose, right? So even though you're just teaching maths to this particular class, you have to be sensitive to bullying and cyberbullying as well. If you do find a case, please do not act on your own. Inform the school authorities. Do not take the matter into your own hands. Alright, let's move on to the first level in Van Heel, which is geometric thinking. Okay, which is level 0 visualization. And you very well know that at level 0 visualization, students use visual perception and non-verbal thinking. They recognize geometric figures by their shape as a whole. They compare figures with their prototype as everyday things, and then they categorize them as it is a cube or it is not a cube in this matter, right? And they use simple language. They do not describe the properties just yet. So you can see in this picture we have many 3D shapes. So your students say that this is not a cube. This is not a pyramid. Okay, this is a pyramid. This is not a pyramid. So if that's the case, then you need to ask them, why do you think that this is not a pyramid, and so on and so forth. Okay, these are items or things in everyday life that they can connect to or link to a certain shape. For example, the first one is a cube, so this is a Rubik's cube. This is a cuboid, so this is a tissue paper box. This is a triangular based pyramid, and that is one in France. Now this is a square based pyramid, and most of square based pyramids are found in Egypt. Now the next one is the cylinder, and we can find cylinder shaped waste paper basket or bin, okay, in shopping malls. So if you have been around campus as well, okay. The next one is a cone, and this one associates with ice cream cone. Now this particular shape here might be new to your students. So this is a prism. It's a triangular prism because the base here is a triangle, and at the end is also a triangle. So because the two base and also the top is the same, that's why we call it a prism. And one example of a prism is Toblerone chocolate. Now this is something new to the students as well, where it is a square base pyramid put on top of each other. So this is one and this is the other one. So we call this square based bipyramid. And we can find this kind of structure or shape in molecular chemistry. So we have here, this is the structure for SF6, which is poisonous sulfur hexafluoride. And you can see that each molecule here is at a certain angle and at a certain plane. So this is the square. And if you connect this central atom to the rest on top and at the bottom as well, you can find that it looks exactly like this. Level 1 analysis. In level 1, we are going to see our students starting to analyze and also name properties. They do not see the relationship between properties. They think that all properties are important, and they can measure, fold and cut, and use geometric software. So there are a few terms that you need to discuss with your students. First is the term polyhedron. So for polyhedron, it means that they are 3D shapes with flat surfaces and straight edges. Now a face is another term that you need to discuss with your students or describe to your students. That is, a face is a flat surface, okay, of a polyhedron. Edge is a line segment where surfaces actually interact or meet. And vertex is a point where 3 or more edges intersect or meet. So the first one is edge, which is a line segment where surfaces intersect or meet. Surfaces here could refer to either a flat surface or a curved surface. Curved surface. Right, so we have two types of surfaces. Now for polyhedron, they have face. They have faces. And faces are actually flat surfaces. So you only use the term face when you see a polyhedron. Now for curved surfaces, you can see that, for example, this cone, it has curved surfaces here, but it also have a flat surface at the bottom. So this flat surface of the bottom is not called a face because a cone is not a polyhedron. So this is called a flat surface. Now for the cylinder, it has two flat surfaces, one at the top and one at the bottom. So when they have these two flat surfaces, and because a cylinder is also not a polyhedron, then these two flat surfaces is called flat surfaces. And the body of the cylinder has a curved surface. Now finding the edge for a cone, is where the surfaces intersect, and as we have seen just now, there are two types of surfaces found in a cone. One is curved and one is flat. So the part where you see that the curved surface and the flat surface actually meet, that is the edge. So this is the edge of the cone. So a cone has one edge, whereas for cylinder, it has the flat surface over here and another flat surface at the bottom, and this is a curved surface. So that means this is an edge and this is an edge. A cylinder will have two edges. Let's take a look at face. For a polyhedron, the face is defined as a flat surface of a polyhedron. And you know polyhedron has flat surfaces, and we call that a face. So this face is distinctively specific for polyhedrons. Now for cone and cylinder, they don't have face, they only have surfaces, even though it's flat. So take for example this part here in the cone, which is flat, but we call it flat surface. And of course this side here is called curved surface. Same case with cylinder. This is flat, the bottom part is also flat, but the middle part is a curved surface. So that means for a cylinder, it has two flat surfaces and one curved surface. So be very careful with the term. Some books, look at the textbook or reference book that you'll be using. Now for vertex, it's defined as a point where three or more edges intersect or meet. For polyhedrons here, you can actually see their vertices, but for non-polyhedrons such as cone and also a cylinder, you have to find it out. So let's go to cylinder first. Now for a cylinder, they have two edges. Okay, the edges are here. One edge, two edges, but they do not intersect. So a cylinder has no vertices. Now for a cone, the edge is here. It's between the curved surface and the flat surface. However, we have an apex over here, which is a point, and this is a vertex. So a cone has one vertex. Okay, we will find out how this cone actually have this vertex. in the later part of this video lecture. Level 2, informal deduction. At this level, your students should be able to perceive the relationships between properties and figures, and they could create meaningful definitions as well as give simple arguments to justify their reasoning. So meaning to say they are able to do geometrical reasoning. So the first thing is that we need to see which ones are polyhedron and which ones are non-polyhedron. So those with flat surfaces and straight edges are polyhedron. So these are the shapes which falls under polyhedron. And non-polyhedron, these are the shapes that are under non-polyhedron. So we can already separate these two groups. Next is looking at edges. Again, based on the definition for an edge, we can actually put them into a different number of edges. So the first one is one edge, which is a cone. The cylinder has two edges. We have discussed this earlier. And for triangular pyramid, it has 6 edges. Square base pyramid has 8 edges. Triangular prism has 9 edges, and this 3 has 12 edges, and our globe or sphere has no edges. Now for face, which is actually a flat surface of a polyhedron. So if it is a non-polyhedron, it will not call a face, it will call surface, either curved surface or flat surface. So for a cone, it has 2 surfaces because it has a curved surface over here and a flat surface over here. For cylinder, it has 3 surfaces, 2 flat surfaces and 1 curved surface. Now for triangular pyramid, it has 4 faces because it is a polyhedron. So since it's a polyhedron, because all the flat surfaces are there, so as you count the faces, you will see that it has 4 faces. For triangular prism and also square base pyramid, they each have 5 faces. And then 6 faces will be cuboid and also cube. 9 faces is for square based bipyramid, and for a sphere it is 0 face. So a little note here that we have 2 types of surfaces. The flat surface is called faces for polyhedron. Okay, for non-polyhedron, we'll still call them flat surfaces, and curved surfaces for non-polyhedron as well. Okay, so again, non-polyhedron will have flat surface or and curved surface, but for polyhedrons, they have face, and face is defined as a flat surface of a polyhedron. Vertex. Let's look at the term first here. We have a new term where in some books they do use this, which is apex. Apex is actually where lateral faces raised from the base to meet at a point. Example, a pyramid. Okay, so an apex. For a pyramid, it has a square base here. Now from this square base, you can see that sorry about the crooked line. Okay, you can see that this triangle actually rises from the square right up to this point. Same case with this triangle here. Same case with the triangle back there and the other one as well. So when these triangles actually rise up from the square base to meet at a point, this point is what we call as apex. A vertex is a point where three or more edges intersect. So an apex is also called a vertex. Okay, so there are so many terms that can be used in geometry. So for a cone, it has a vertex here. This is 4 vertices. Okay, for a square base pyramid, it has 5 vertices. And for a triangular prism, 6 vertices. This is the square-based bipyramid. Okay, and these are 8 vertices. Okay, you have to draw the dotted lines, the only that you can see. And then for cube, right, for cylinder and the sphere, they don't have any vertices. For a cone, you might be wondering why a cone has a vertex. Okay, this is the explanation. If you cut across, okay, a cone, you can see that it has a right angle triangle like this. And right angle triangle, if you rotate it 360 degrees, you will get a cone. And because of that, the right angle triangle has a vertex here. So 360 degrees, the vertex is still there. So that's why it has one vertex. A cone has one edge. Remember the edge over here? Okay, because of the curved surface meeting the flat surface. Okay, so it has two faces or two surfaces. Okay, correct that. Two surfaces, the curve and the flat. Here are the geometrical terms for 3D shape: polyhedron, edge, vertex, face. Lateral faces is a face of a prism or pyramid that is not the base. So the one that I explained just now is actually called lateral faces.